time around we are talking about deep copy. Deep copy simply means that you want to copy an object such that for all the properties of this object that you can reference through the key, either the values of these properties is a primitive values or is a reference object, you are going to implement a new copy of it instead of the reference, which is what we call a shallow object. So for example, we have an object here with a key of A referring to a primitive value of 1 and a key of B referring to a reference object of this object with a key of C and value of 2. So after implementing a deep copy, when you want to modify either the primitive values or the value within an object that belongs to the properties of the original objects, these changes will not be reflected into the original objects, which means by modifying any values within the copy, the original object will not be affected. Yeah, so let's draw a graph here. So let's say we have an original object with a key of A referring to a value of 2, with a key of B referring to an object of 3. So by building a deep copy, it will have a value of A and a new value of B, such that if you want to modify the values of either here or here to 3 and this one to 4, the original objects will not be affected. Yeah. So it's a simple theory. Yeah, so let's start with the code. The implementation is pretty straightforward. So first, we want to do a base case check to check if the objects passed in is indeed an object. So if it's passing a null, or the object being passed in is not an object, but it suggests a primitive values, then we are not going to copy it because deep copy only applies to objects. Right? And then we know that there is two types of objects to be copied, which are array and object. Right? So array and object. So we want to check if the object that we are going to copy is an array or is it an object by using a simple check of array.isArray here. Yeah. So after this line, we confirm that we are going to duplicate this array or object. Then we will need to iterate all the keys that belong to this object, such that we can get every single properties under the original objects and copy it. So to iterate the object, we can use the for in expressions. The for in expressions, yeah, to get all the keys belong to the objects. One thing you need to note is that for in will not only obtaining the key belong to the object, but it also obtains the keys belong to the prototype of the objects and the prototype of the prototype of the object. So any prototypes that lies above the objects along the prototype chain will be reflected. So for in, reiterate all the keys lines along the prototype chain of the object. So we also want to make sure that we doesn't include the keys which belong to the prototype of the object instead of the object itself. So we use has own property ensures the key is indeed belong to the object itself, not the prototype. Of it. Yeah. So by simply calling object.has own properties, we'll check if the keys belong to this object. So what if we ensure that our object has such a key? Then there's two ways of copying. So the first case will be copying primitive values. So which is here, copying primitive values. Something like integer, like just number, or string, characters, or just simple booleans. Those things that doesn't belong to a reference object. But if you are copying a reference object, something like an array and object, then we need to adopt recursions to copy the objects that lies under these objects, right? So which is also pretty simple. So we want to run this deep copy recursively so that the properties of these objects is being copied and put into the new objects. Yeah. So if just a simple primitive values, something like a 1 or a false or a character C, these kind of things are called primitive values. So they will be copied directly into new objects. After that, we simply returns the new objects. Yeah, it's a pretty straightforward implementations. So, yeah. Let's test our code. Let's say we have such an object structure with a key of A referring to a primitive value of 1, and with a key of B referring to an object which is something like which has a key of C pointing towards a primitive value of 2. So these are the two properties that lies in these origin objects. After copying these objects, we want to modify the values of the copy objects such that we change the number of A from 1 to 2, and we change the reference object in the original object copies from such that we are changing the primitive value within that referencing object. Yeah, so by doing so, we are expected to have original copies that not affected at all, while apply our changes to the new copy only. So this is the expecting console output. And let's check. Let's run the code using simple Node.js. Deep copy.js. Yeah, sorry, didn't save the previous stuff. This is a mistake. So you can see that if we want to output the objects, you need to apply toStrings method on it. If not, what we output will simply be the type of the object. Right. So let's run this code again. There, toString. Yeah, so you can see that for the updated copies, the changes doesn't reflect into the original copies. Doesn't matter the properties is the primitive values or is the objects. Yeah, so we have done a deep clone. So that's all for these sessions.